In this lesson, we're going to look at solving equations. So the first thing we need to know is what it means to solve an equation. It means find the value of the variable that makes the equation true. And an equation is true when the left side is equal to the right side. So you find the value of the variable that makes the left side equal to the right side. And basically there's one step, although it may take more than one step in order to do it, but that is to isolate the variable on one side of the equation by using inverse operations. And then the rule to follow is that any operation done on one side of the equation must also be done to the other side. And we'll do quite a few examples just to make that very clear. So we've got 4 examples here to start with, and we're going to isolate the variable, so get the variable by itself on one side of the equation by using inverse operations. So in example A, I have 5 times x equals negative 15. The inverse of multiplication, so think of the operation that's happening to the x. The inverse of multiplication is division, so what I'm going to do is I'm going to divide both sides of the equation by 5. 5 divided by 5 gives me 1, so I have 1x now, and negative 15 divided by 5 gives me negative 3. So my solution is x equals negative 3. The value of negative 3 in x makes the left side of that equation equal the right side. 5 times negative 3 equals negative 15. In question B, I have x minus 7 equals 12. So the inverse of subtracting 7, the opposite operation, in other words, would be to add 7. So if I add 7 to both sides of the equal sign, on the left, I'll now have x, because negative 7 plus 7 gives me 0. And on the right side of the equation, I'll have 19. So x equals 19 is the solution to the equation. And if you think about replacing the value of x with 19, 19 minus 7 equals 12. Let's look at C now. We've got t plus 12 equals negative 2. Notice that I'm adding to the t on the left side of the equation, so instead I'm going to subtract. I'll use the inverse operation so that I get the t, or the variable, by itself, or isolate it on the left side. So if I subtract 12 from both sides of the equation, I'll get positive 12, or adding 12 minus 12 gives me 0, so I'm just left with t equals, and negative 2 minus 12 will give me negative 14, and that's my solution. And one more example here. N divided by 2 equals 6. The opposite of dividing by 2 would be to multiply by 2. So if I have n divided by 2 times 2, that's going to give me 1n equals, and then 6 times 2 gives me 12. So my solution is n equals 12. And if you think about it, 12 divided by 2 equals 6. So the value of 12 makes that equation true. Let's add a couple of more steps, though, to isolate the x. So in question E and F, I do have an x on one side of the equation, but I have other operations as well. So if you look at 5x minus 2, we're going to take a couple of steps to get the x by itself. The first thing we'll do is add 2 to both sides of the equation, and then that x term will be by itself. So if I add 2 to the left, I'm left with 5x equals, and negative 17 plus 2 gives me negative 15. Then I can divide both sides by 5 so that I get 1x equals negative 3, and there's my solution. So we can just peel away the operations from the x to get the x term by itself, and almost always our final step will be to divide by the coefficient of x so that we get 1x in our solution. If you look at question F, I have x's on both sides of the equation. I've got one on the left and I've got one on the right. So my first step might be to just get x by itself for a minute there on one side of the equation. So I could do that by just subtracting 2x from both sides of the equation. So I subtract 2x from the right side, I'm left with 1. If I subtract 2x from the left side, I'll have 4x minus 5. Now this looks a lot like question E, so let's add 5 to both sides so that the x term is by itself. And so then on the left, I'll have 4x, and 1 plus 5 gives me 6. And now to get 1x, I'm going to divide both sides by 4 so that I get 1x equals 6/4, or x equals 3/2 as my final answer. All right, let's move on to fractions, everybody's favorite. If you have fractions in your equation, you can treat them just like you would the other numbers, and you can just isolate your x or your y or whatever your variable is. However, especially with a more complicated fractions equation, it's really nice to be able to get rid of the fractions. And there is a nice little trick to do that. The trick is this: if you look at all of the denominators that are in the equation, so on both sides, any of the denominators, so I've got the 3 and the 12, you can see that the lowest common denominator is going to be 12. Multiply every term on both sides of the equation by 12. So I'll have 12 times 1/3 plus 12 times y equals 12 times, and because I'm multiplying fractions, I'm going to turn that 4 and 7/12 right away into an improper fraction. So that'll be 55 over 12. And the reason we chose 12 is that it right away cancels out or simplifies out all of the fractions. So on the left side, I've got 12 times 1/3, but that gives me 4. 4 plus 12y equals 55. So now I have a much simpler equation, no fractions left in it. Let's subtract 4 from both sides. So I have 12y equals 51. And then we can divide both sides by 12, and I'll have y equals 51/12, or 4 and 3/12, which would be 4 1/4. Sorry, I didn't quite leave myself enough space for some of these here. So let's do that same method for question H here. I've got -5/4 x equals 10/3. If I look at the denominators, I've got 4 and 3. My least common denominator happens to be 12 again. Let's multiply every term on both sides of the equation by 12. So I have 12 times -5/4 x equals 12 times 10/3. And again, we're going to be able to simplify on both sides here. Our numerators with our denominators, so now I have -15x equals 40, and I'll divide both sides by 15. Actually divide by -15 because I want what 1x is. So x equals, and it'll be -40 over 15, but we'll simplify that by dividing by 5. So we'll have x, let me just do that properly here. So we have x equals -8/3, or -2 2/3. So multiply both sides of the equation by the least common denominator, and your fractions will Checking our answers is really a neat thing that you can do with solving equations, so you can always check that your answer is correct. We do this by substituting our solution into the original equation and simplifying the left and right sides of the equation. If the left side is equal to the right side, then the solution is correct. I've recopied questions E, F, and G from the previous slide, and I'll show you how we check those solutions. So for question E, we said that the solution was -3. X equals -3. So we'll just substitute that into the equation and see if the left side equals the right side. So I have 5 times -3 minus 2 equals -17. I replace the x with a -3. So the right side's already simplified, and the left side will be 5 times -3, which is -15, minus 2, which is -17. So the left side does equal the right side. So our solution, x equals -3, is correct. Let's take a look at question F, and the solution that we had was x equals 3/2. So we'll substitute the 3/2 into the left and right side. Into both of those x's need to be replaced with the 3/2. So I have 6 times 3/2 minus 5 equals 2 times 3/2 plus 1. So on the left side, 6 times 3/2 will give me 9, minus 5 equals 2 times 3/2 will give me 3 plus 1. So I end up with 4 equals 4. So the left side does equal the right side. So the solution that we had is correct. And then for G, we had y equals 4 1/4 as our solution. So we'll substitute that into the equation, the original equation, and see if we get the same solution. So I've got 1/3 plus 4 1/4 equals 4 7/12. Luckily, the right side is simplified, and the left side we're adding 1/3 to 4 1/4, so we need common denominators, which will be 12. So we'll have 4/12 plus 4 3/12, which gives us 4 7/12 equals 4 7/12. Left side equals the right side, so our original solution, or the solution that we got, is correct. It's such a nice thing to be able to do, to check your answers when solving equations, especially as they get more and more complex as we move further along. And that's it for this lesson.